Simple interest. We have different types of interest: simple interest, compound interest, continuous compounding, annuities. Let's identify them, because ultimately, when we're given a problem, we need to know which formula to use. So we have to go by keywords. For loans of a year or less, the usual thing is simple interest. The interest is paid only on the amount borrowed, not on past interest. So we don't keep accumulating interest. This is a formula for simple interest. I, which is interest, it's money. PV is present value. This would be the loan or the investment amount. R is easy to identify. That's the rate. That's the percent number. And time has to be in years. When you're working with money, time is in years. Here's a simple interest, a future value of simple interest. The previous one we just saw was just find the interest. This one is, if I invest in the present this amount, and I let this amount of time go by, how much would the money that I invested become in the future? So the future value of the loan or the future value of the investment. This is the one. So find the maturity value and amount of interest paid. So we're going to practice. So find the maturity value. Maturity value would be the future. Maturity happens in the future. So when they say maturity value, they mean the future value. So High borrows $20,000 from his parents at 5.25%. He plans to repay the loan in 9 months. So first step, identify which formula you need to use. Well, it says that he borrowed $20,000 from his parents and he plans to pay the loan in 9 months. So that's a year or less. So think of simple interest. So it's a simple interest formula. So you write this formula down. Now go and read the problem and identify what they've given you. He borrowed $20,000. So that's the present value. They said the rate was 5.25. So that's the R. Then move the decimal twice to the left, and that's what you're going to key into the calculator in the formula. They said the time was 9 months, but we said that the formula only accepts years. So change the month to years. 9 months out of 12 months is 3/4 of a year. Now plug it in. They take their positions. Simplify. So he borrowed $20,000, but he has to pay $20,787.50. Right here, we can see right away that the interest, the extra amount, the interest is the extra amount they pay me or I pay them. In this case, he's going to have to pay $787.50 extra. Here's the interest formula for simple interest. You could also use the second one. The advantage of the second one is that this one can be used for simple interest, compound interest, continuous compounding. This one can only be used for simple interest. So this is more general. So notice the problem we just did. We take the future value. That means what he owed, what he borrowed. The difference would be the interest. And we found the interest using this formula. Here's another problem. So this problem says Jalinda owes $5,000 to Madison. The money must be paid in 10 months with no interest. Suppose Jalinda wants to pay the money today so that Madison can invest it at an annual rate of 5%. What amount should Madison be willing to accept to settle the debt? So Jalinda owes $5,000, but this is going to be paid in 10 months. So if Madison needs the money now, how much should Madison be willing to accept now if he's not going to wait for 10 months? Okay, so in the future, Jalinda was going to pay $5,000. In 10 months, Jalinda was going to pay $5,000. So in the future value would be $5,000. In 10 months, well, how much is 10 months in years? 10 out of 12 months. You could reduce this. And the rate is 5%. Change it to a decimal. But how much should Madison be willing to accept now? Well, now would be the present. So we have the FV value, we have the R and the T. We need the PV value. In the present, how much should Madison be willing to accept? So you solve for PV, move this by dividing both sides by this amount. And now plug in the numbers. So Madison should be willing to accept now, in the present, $4,800.